Okay, today we're going to be looking at graphing rational functions, and we talked about inverse variation equations, and these are examples of rational functions. And we're usually looking at the most basic format of that equation as y equals 1 over x, which is the graph that we see here. And so we're noticing that there are certain x values, there are certain values in our domain where there are no points. So if we look right here, we can see that they're approaching this y-axis, but none of the points actually fall on the y-axis, and that's because that would be our excluded value. When we have the equation y equals 1 over x, we cannot have a denominator of 0. That would be undefined. So we have to look for values in our denominator that are not part of our domain. So 0 is not part of the domain of this graph. Our domain would be all values less than 0 and all values greater than 0, but 0 is not part of the domain. So the first thing we want to do is we actually want to go ahead and look at our equation and find the excluded values. So that's the values that would make this denominator equal to 0. So x plus 5 equals 0. So x equals negative 5. This is not part of our domain, so it is an excluded value. So we're going to go ahead and we're going to graph this. And again, the first thing we want to do is look for that excluded value. And so we have x minus 1 equals 0. So x cannot equal 1. So when we're making our table of values, we want to do a few values smaller than 1 and a few values greater than 1. So we're going to do negative 2, negative 1, 0. 1 is our excluded value, 2, 3, and 4. And so we're just going to create a table of values for x and y. When we plug in negative 2 into our equation here, we would have 1 over negative 2 minus 1, so that would be negative 1/3. Here we would have 1 over negative 1 minus 1, so negative 1/2. Here we would have 1 over 0 minus 1, so negative 1. This would be undefined, so that's our excluded value. Then we would plug in 2, so we would have 1 over 2 minus 1, so that would be 1 again. 1 over 3 minus 1, which would be 1/2. And then this would be 1 over 4 minus 1, so 1/3. So we're going to go ahead and draw our graph and graph those points. Okay, so we have negative 2, negative 1/3, which would be like right here. We have negative 1, 1/2, which would be getting a little bit lower. We have 0, negative 1, which would be here. So we can see our graph kind of going like this. And then over here we have, cannot be negative 1, so we're going to actually talk about that's kind of a special value right here, this line. Then we have 2, 1. Then we have 3, 1/2, and 1/3. So again, our graph is kind of going like this. And we can see that our domain is values less than 1 and values greater than 1. So x can be less than 1 or x can be greater than 1. That would be our domain. In our range, we can see we have all numbers except we don't have anything in here, right? So we don't have any x values, y values of 0. So y is greater than 0 or y is less than 0. Okay, we're going to talk about those values that we've seen our graph approaching but not touching, and those actually are called asymptotes. And asymptotes are those vertical and horizontal lines that the graph approaches, but it never actually intersects. And so we're going to look at how to find the vertical asymptote and the horizontal asymptote. using the equation in the format y equals a over x minus h plus k. And obviously a can't be 0. And our vertical asymptote is going to be at x equals h. And our horizontal asymptote is going to be at y equals k. And so we're going to be looking at those values. So here we go. The first thing we're going to do is we're going to identify our asymptotes. Let's remember our equation is a over x minus h plus k. So we'll start with our vertical. Our vertical asymptote is at the point x equals h. And so here's our h value, which is 2. So x equals 2. So we know that that is excluded from our domain. And then our horizontal is at the point y equals k, and our k value is -4, so y equals -4, so that is an excluded value. So that tells us our domain is all real numbers except 2, and our range is all real numbers except -4. Okay, we're going to do the same thing again, and then this time we're going to talk about how our graph shifts. So let's find our excluded value. We know that this cannot equal 0. So we know that our excluded value is at -2. So when we make our table of values, that -2 goes in the middle. Then we're going to look at -3, -4, -5, and then we'll look at -1, 0, 1. Okay, so if I'm plugging in -5, I would have 1 over -5 plus 2 plus 3. So I would have 1 over -3 plus 3. So this would be 2 and 2/3. I'm going to do the same thing here. I'm going to continue to create my table of values. And if I plug in this, I would have 2.5. For 3, I'm going to have 2, 1. This is undefined. Nope, this is not 1. This is undefined. And then here at -1, I would have 4 and 3.5. And I would have 3 1/3. Okay, so I'm going to go ahead and graph this. And my graph and just as a reminder, our base graph y equals x squared. I'm going to draw that one in black just so we can kind of remind ourselves what that looks like. It's going to look like this, roughly. And I'll graph this one over here in red. It's approaching that 3, but never getting close to it. So 2 1/3 would be about here. And then 2.5. And then 2. So we're kind of going like this. And then this side, we're doing the same thing, but we're up here. This is going more like this, I'm sorry. And then here. So we can see that value here that we're approaching. Okay, so what we want to notice if we're comparing the two graphs, oops, I accidentally deleted this one, is that we've shifted up And we can actually see that shift right here. So we're up 3 units. And we've also shifted our graph to the left. And so we can see that right here, left 2 units. So that K value tells us if we're moving up or down, and that H value tells us if it's a shift to the left or to the right.